Okay, so we're going to do 1.2 exponents and radicals. We're going to learn about the objectives, or the objective is to learn about the exponents. So I know you guys have already seen this. Okay, do me a favor, try those up on the little warm-up part right there. See if you remember how to do some of these. Good. If it's easy, good. Okay, this should all be review. I think the radical portions, when we deal with fractions, becomes a little bit more trickier and more difficult. But we'll be okay. We'll be okay. If you need to use a calculator, you can use your cell phones. I'm definitely okay with that right now. If you need a calculator and you don't want to use yours, I have one back there. Calculators are definitely going to be acceptable on the test, so mine are definitely going to be able to use them. Hold on, let me see. Yeah, we should be okay. Yeah, we'll be all right to use them. Depending on how you want to type them up is going to be important. A lot of my handouts that you guys have in front of you will go in logical progression, so it's going to go in order. You don't have to put them all vertically down. You guys can separate them as long as they're in the same section. It'll help you guys out. Just trying to save some space for some of you guys. What does the exponent 2 to the 5th do? What does it basically do to us? How do I show that as a multiple? What would it be?
2 times 2, 5 times.
2 times 2 times 2, 5 times. The exponent tells us how many times our number is multiplied by. 32. Okay. Next one's doing the same thing. Essentially what we want to be able to see here is that we're going to be multiplying 1/3 times 1/3 times 1/3 3 times. If I'm multiplying fractions, I multiply directly across, so 1 times 1 times 1 is just 1. 3 times 3 times 3 is 27. Okay. The one down below from that, we want to be able to see how these are all kind of situated. If the negative is in the exponent, that means the number is included, so we would multiply this by -3 times -3 times -3 4 times. Okay. You can do it separately, so we can do our first two numbers here. Bless you.
Thank you.
9 and 9. 9 times 9 would be 81. The difference is with the bottom value, if it's not within that parentheses, we have to separate it. So it'd be -1 times 3 times 3 times 3 times 3. So 3 times 3 times 3 times 3 is still 81. We're just going to do -81. So know the difference when we get some of them inside the parentheses and out of the parentheses. So keep that in mind. Okay. How many people are good with exponents? Really good with exponents? Okay, we'll see. There are some tricky problems on here, okay? Here we go. Second part of this is just being able to look at the notation, okay? If any real number is in the n positive integers, we say it's the nth power of a, okay? This is called the base number, and n is called the exponent. So a is the base, n is the exponent, okay? If we're going to be applying some of these, and I think we already did these, right? For some of them, it's okay. And all I'm going to do for these ones, for these base numbers, is our base number is a half. Because we already did these, right? Yeah. Okay. Our base numbers are half. The exponent is our 5. So that's all we're going to do for these ones. Other ones we're going to do work, but our base number is going to be -3. Our exponent will be 4. Then our final one, surprisingly, our base number here is 3, and our exponent is 4. You can look at the bottom value of this being like -1 times 3 to the 4th. So we still consider this our exponent. Okay. If the numbers are too small on that and you need to have it on a separate sheet of paper, by all means, please do so. I never want you guys to just like write tiny and then forget about it later. So it's up to you. This is just to help you guide your notes, because I know it'd be a pain in the butt to write everything down, right? Okay. So keep that in mind. Keep that in mind as we do these, okay? Here we go. Zero and negative exponents are going to be coming a key as well, especially when we start doing more of the trig and stuff, when we start eliminating terms. If our base number is not 0, then the nth power does the following 2 properties. Anything raised to the 0 power is always going to be 1. Any values that give us a negative exponent will flip that base number into a fraction to the exponent. This is going to be a very key one when we start doing stuff later. We're going to start looking at more and more, looking at inverses, how to apply them. Do you guys remember doing a lot of those back last year? Flipping them? When looking at our examples, the easiest one to do is letter A, not number A. Letter A. Anything raised to the 0 power is what? 1. Perfect. Simple and easy. No matter what it is, as long as the base number is not 0, you're always going to raise it to the 0. So if it's raised to the 0 power, it's always going to be 1. Okay. The next one we see here is that we have x to the -1. So what I would do is I would change it for a fraction, 1 over x to the first. Anything raised to the first power is just by itself, so this is just going to be 1 over x. Last one down below, we have another exponent that's raised to a negative value. So this is going to be 1 over -2 to the 3rd power. Multiplying these out, -2 times -2 times -2 gives me what? Positive or negative? -8. I do want you guys to simplify as best as you can. If you guys need help with that, please let me know. Okay, in this case, we can not simplify it because 1/8 is not simplified. Cannot be simplified. Okay, here we go. We're going to do more problems. Okay, our laws of exponents are going to be crucial when doing a lot of the manipulation, manipulating terms and exponents. I've given you a little section right here. I'm hoping you guys can see it. These are going to be a bunch of where our problems are going to be. So I'm hoping you guys kind of see that. If you need more room, please do so in the backspace in the back if you need more. Okay. The first part of this, rule number 1, is any numbers or any exponents with the same base, you can add the exponents. Okay. Same base, we can add the exponents. So this is going to be 3 to the power of what? 3 to the power of 7. So it's going to be 3 base. It's going to be 2 plus 5. You do? Good. Sweet. Be adding up the bases. It's going to be 3 to the 7th. I'm going to go ahead and just leave it. I know you guys know how to calculate 3 to the 7th. It's not what I'm worried about. If you have the same base number and they are dividing, that means you can subtract the two exponents, the top from the bottom to top as well. So this will be base number is still the same, so it's going to be 3 for us. And all we're going to do is 5 minus 2. Three to the third. If you're raising an exponent to another power, you multiply the two exponents. So in this case, we're going to have 3 times 2 times 5. This will be 3 to the 10th power. It's a really, really big number. Multiplying two numbers or two different bases, or in this case, your base number is consisting of two different factors. You can distribute the outside term to each value inside the parentheses. So it'd be like distributing this n to the a, n to the b. So it'd be 3 squared and it would be 4 squared. If they're just two numbers, you can also just multiply a and b together to simplify it out. I'm okay with that. Okay, but in case we get different variables that we have to kind of solve for, we've got to be able to do that. Same thing applies when we're having a base number outside of a rational base. Okay, we want to be able to basically distribute that exponent to both the top and the bottom. So it'll be 3 squared over 4 squared. Good stuff? Come on. Why don't work so? Let's see if this fixes it. The next one we want to be able to do is looking at negative fractions. Okay, looking at negatives. These are going to become crucial in a little bit as well. The negatives are always going to be tricky for you guys. At least they were tricky for me. Whenever you have a negative in an exponent for a fraction, so your base number is a rational fraction or fraction, you want to be able to flip it. So we're going to flip it or do the reciprocal of the fraction and then still distribute the base number. So in our example, 3/4 raised to the negative second power, we're going to do 4 over 3 raised to the second power. And then that's going to also become distributive. So 4 squared over 3 squared. It's better to do it out early. Again, I'm sorry if this is small. Try to fit as much as I can so you guys can use it later. If you have a rational exponent for your numerator and your denominator, all you're going to really do is just flip them. Okay. The negatives go to the top. Your top exponents go to the bottom. Your bottom exponents go to the top. So it's essentially what we're doing is we're making these two flipped, and we're making our exponents positive. So this will be 4. I'll just do this down below. This will be 4 to the 5th over 3 squared. And again, I know you guys know how to simplify that out, so I'm not too worried about that. Is this one of the last ones in the back? Or how about this? Last one in the front, right? Okay. All these ones are going to be a combination of everything we're going to do today. Okay, so we're going to look at some problems, and I'll give you guys some work to do. Okay. So on the flip it to over the backside, you're going to kind of flip back and forth with it if you need help. Okay, hopefully you can remember. Here we go. Let's look at some examples. Look at these. Try some of these. Also, raw. First number, they had the same base, yes? What can we do with them? Add them. They're still going to remain the same base? Yes, I know you guys don't have to show this part, but I'm just going to show it for the ones that need help. 4 and 7 is what? 11. Next one. Do that same base?
Yeah.
What can we do with them? Subtract them? Okay. Essentially what you're doing is you can still add them, right? Doing the same thing. Our base becomes the same thing. It'd be like 4 plus a negative 7, so you're just going to subtract them. You're going to get y is equal to negative 3, or y to the third power, sorry. And then because it's a negative, what do we do? Put it as a fraction. 1 over y to the third power.
Is that the answer?
That's the answer. Yeah. Yeah. Here's our answer. Bottom one, not the same bases. So we got to do them each part by themselves. Our 4 to the negative second power, what do we do? 1 over 4 to the second power. And then our 3 squared just becomes what? 9. I'm going to put 9 over 1. We can simplify this out a little bit further by multiplying across. 1 times 9 is just 9. 4 squared is what?
16.
16 times 1. Try and trick you guys up. Can 9 over 16 be reduced? By what? 3/4. 3 by 3. Can it be reduced?
No, I don't think so.
No. I know what you're trying to do. Not that. Not that. We can't reduce that. If it was 15, we could. Right? 15, we could. So we can't. Okay, here we go. Let's try some more. Here we go. We're taking an exponential and raising it to another power. What do? Multiply. We're going to keep the same base. And we're going to get 4 times 5, or b to the 20th power. Beautiful. E, we have 2 separate values, right? This is the a times b raised to an exponent. So what should we do with each one of those? Distribute. So we're going to distribute each term, the exponent, into each term. So this will be 3 raised to the 3rd, x to the 3rd. Beautiful. 3 to the 3rd, 27. F, we have a rational for our base, and we have a ratio. Raised to an exponent, what do? Distribute to the top. And then we also want to distribute to the base as well. So it's going to be x to the 5th over 2 to the 5th. 2 raised to the 5th power. Beautiful. How do you guys like the pace that I'm going right now? Is it okay? Okay. Foundations, man, before we get to the crazy stuff, right? Gotta build it up.
Just skip the crazy stuff.
Skip the crazy stuff. A's for everyone.
Yep.
That's how we do it. I wish that was the case. Okay. Here we go. We're gonna kind of do a little bit more. Hopefully you'll allow me to. I don't know what happened. Okay, here we go. Let's see it. Went up my screen. Okay, here we go. Some more problems. They're jumping up. Hold on. I got you. Don't worry. Did it change at all? Let me see. Give me a second. Let me see. Let me see these right ones. Yeah. Okay. Show you how to go about them. Get it a little bit more complicated, more variables, but the rules still apply. Okay, we're going to look at the same kind of rules and just do them chunks by chunks. In pre-calculus, you definitely want to see patterns and how everything's done. So this is the way that you kind of want to see it. If you're confident in your exponent game, go for it. If you need help doing it, I'd be more than happy to show you. We're going to do radicals tomorrow. We'll take a quiz on Friday, and if I can start the next section on Friday, we will. If not, I'm not going to trip. I'm not going to trip, man. Okay. Here we go. Let's do. Okay. You're going to change for me, you know? Our first one that we're getting here, our group terms right here. Are you kidding me? It doesn't want to write. Come on. Let's try this again. It's getting a little sketchy on me right now. Give me a second. Don't do this to me. Let me see this. This should just drop it down the wrong time. Thank you. Show me what I can work with. Awesome. Freaking out over me. One second. Try this again. Yay. Okay. Our first group of terms right here, 2a to the third b squared, has really nothing. There's really nothing we can do for our exponent. It's not raising anything. We can't combine them. So we're just going to bring this one down. 2a to the third b squared. Our second term on the side, though, has something different, right? We have it raised to an outside power. So what do we do if it's raised to another power? Distribute to each term, right? So to the 3, to the a, and to the 4. So this is going to be 3 to the third, a to the third, b to the what? 12th, right? We multiply them when we raise it to another power. Now that we have them all together, we want to kind of reduce terms down. So I'm going to look at my whole numbers, 2 and 3 to the third. What's 3 times 3 times 3? 27 times 2? 50. So we're going to get our first terms, just multiplying those two out. You can easily do those in a calculator, okay? The next ones that we're going to get here is our a. So we're going to try to put this in logical order. Okay, they have the same number. They're right next to each other. So what do we do with them? Add them. So this will be a to the 6. And then we have our last terms as well. We have our b squared and our b to the 12th. Again, they're right near each other. So it's going to be b to the 14. You could have also taken another step if it helps you out and just re-separate them or just group them in terms. So you could put 2 times 3 to the third as a group of terms, a to the third times a to the third, and b squared times b to the 12th. Okay, so you could do it that way as well if it helps you out, whatever works. Okay, all I'm doing is I'm just grouping them. Okay, the next one on the side, we're going to be able to see here that we got to distribute because we're raising a rational to a exponent. So we're going to go ahead and distribute this 3 into each term on the top and on the bottom. I'm not going to group them yet because I just want to break this into chunks, especially when you get the more trickier problems. It's easier to do it this way. We have our exponent again for the second one as well. So we're going to distribute that to each term. The top one's going to be y to the 8, x to the 4th, z to the 4th. The next part that we want to do is just multiply across, group terms across before we simplify out. I know we can kind of cross terms out if you definitely want to do that. I like to reduce down in case I forget anything. So my x's can be moved together. So x to the third and x to the 4th gives me x to the 7th, y to the 8th. And all I did is I grouped them in the same order. So I want to make sure that x goes before y. And then our bottom terms as well becomes y to the 3rd, z to the 4th. We can't reduce any of those downs, right? Y and z's are not the same basis. Okay. The second part that we get here is I'm noticing that we have a group of y's over each other. If we have a group of y's over each other and they're being divided by each other with the same base, what can we do with the fractions? We can subtract them, okay? Or you can basically eliminate the exponent power, right? You can cross out how many terms on the top and bottom. Okay. So this will be x to the 7th, 8, or take 3 y's away from the top 8 is going to give me what? Y to the 5th. Right? You can basically do that again. So y to the 5th, z to the 4th. Can't reduce any more down than what we have in front of us. Okay. Cool beans? How much more time we got? Here we go. Copy down those. I'm going to go ahead and jump right into these so I can give you guys some time to do your homework. I didn't give you guys that many today. Let's see. Check it out. The first thing that I want to be able to look here is see how the negatives are being done. In this case, we have a fraction with our exponents, and it's being with this t to the negative 4 and the s to the negative 2. If we ever see that we have fractions like that, what do we do to those two with negatives? Switch them, right? The bottom goes to the top goes to the bottom. This will be 6s, and then our bottom s squared will be up on top now. All over 2 remains the same. The top t goes to the bottom, so there's going to be t to the 4 on the bottom now. And then our last term, t squared. You guys can probably already see what's going to happen. We're just going to go and simplify down. So 6s to the 3rd over 2 t to the 6. 6 and 2 becomes what? 3. So 3 s to the 3rd t to the 6. Can't reduce this down any further. Good. Next one, we have a fraction raised to a negative exponent. So what do we do with that one first? I would do something different before we did that. Switch it, right? Reciprocal it. So 3z to the 3rd over y, and then we're going to raise it to the 2nd power. Now we have it raised to the 2nd power, so therefore we can do what? Distribute now, right? So we're going to get 3 squared times z to the what? 6 y squared. So we're going to just take that exponent, and we did distribute to each one of those. Simplifying this one down, 3 squared is going to be 9. Z to the 6, y squared. Can't be reduced down, not the same basis. That's an answer. How are we doing with this stuff? Good? Good. Is this good review to go over? Yeah? Good. Okay, here we go. I think that's the last one. Give me a second. Try those out. I'm going to go ahead and pass out the homework. I know, they're getting pretty gnarly. I think you guys can do it. Outside first. Sure. Ten. Over 40. So there's like 1, 2, 3, 4, 5, 6, 7. Only 8 problems tonight. Blown up, man. My wife. Keep on to that paper. You're going to use it again tomorrow. We're going to do more problems on there. So don't forget. Yes. It should be number 10 and then 47 through 40 odd. You only have 8 problems. They get pretty gnarly, so just take your time and practice them. It says it on your paper too. It says it right up on the top. I got you. Change it for you guys this time. Okay? Good? Grouping our terms up, I'm going to go ahead and just group them. So 1 or 12 over 2, or 12 over 2 is going to deal with my whole numbers first. Just get them out of the way. I have my x's with the same base, so it's going to be x to the 7th. And then my y's are going to be grouped, so it's going to be y to the 5th. 12 divided by 2 is 6. X to the 7th, y to the 5th. Done. I'm going to go ahead and group across before I kind of do this. I see that I have an exponent on the outside, so I want to take that and distribute to each term. 2 squared, 2 to the 6th, 3x to the 4th is going to remain the same. There's nothing that we can do with that yet. The bottom, I see that it's raised to another power, so it's going to be x to the 12th. I'm going to group everything and simplify first. So, sorry. 2 squared is 4. 4 times 3 is 12. My x's can be joined together. X to the 10. And the bottom is going to be x to the 12. We can reduce this down by subtracting them. So this would be 12x to the 10 minus 12, if you want to write it that way. Or you can just take 10 away from the top on the bottom. This is going to be 12x to the negative 2. If you left it the other way, you can also have it as 12 over x squared. So either one works. I know some of you guys probably converted it back. It doesn't matter to me. What I see here first is I see the negative on the outside of this term. So what I'm going to do first is I'm going to flip everything before I even flip it again. You guys want to pack up? I'm fine with that. I'll finish this up. Like that. Then we want to flip again with our negatives.
I left the extras on.
Yeah, thank you, bud. Bye, guys. Take care. You guys are more than welcome to leave.
See you later.
We'll see you guys. Have a good one. I'm going to reduce. You guys too. like that, then reduce down a little bit more. Bye, guys. We'll see you. Have a good day. We'll see you again. How did today go? Good?
Amazing.
Good? Good? Everything went good?
Yeah.
Feel comfortable?
Yes.
Comfortable? We're good? Awesome. We'll see you, bro. Good job.
You want yoga or something?
No, I'm good, man. Can't have that, man. Trying to lose that. Trying to lose that weight.
Still on your diet?
Yeah. I want to lose another 40 pounds.
How much?
Another 40 pounds. I was at 280. I want to get down to. Oh, I want to get down to 180. So about 100.
Yeah. That's crazy.
I'm gonna get there.
It's a lot.
It's a lot. It's a lot.
It's a
But
lot.
I feel like I can do it.
So you've been, because you lost a lot from
I lost a
how
lot.
you were before already. Like,
I just started June
how'd you do
1st.
it?
I'm on a program. It's called Activia. And it's good, man.
Oh, you're really on